Hello, welcome to week one of our vocabulary. We'll be doing this every week, 8 to 12 vocabulary words that are good to know. The best way to do this, watch the video. If you need to refer to the PowerPoint, go right ahead and then go take the vocabulary quiz. And we will be speaking in greater detail of all these concepts later on, but I want to give you a general idea of what they're about. So our first unit is motion. And to understand motion, you have to think about things like, right now, I don't feel like I'm moving at all, but we are actually moving at a very fast speed. The Earth is spinning, the Earth is going around the sun and all the planets are going through the galaxies are moving. You're actually moving at a tremendous speed, but it doesn't feel like it. You don't feel it, you don't see it. So when you talk about motion, it's relative to something else. We call this a point of reference. So if you're driving in a car, you notice that the speedometer is broken and you want to know, are you going too fast or too slow? Looking at the sun would not help you. Looking at a distant mountain would not help you. Certainly looking at the person sitting next to you, they look like they're sitting still compared to you. Now, you need a frame of reference of something that is close by but is not moving itself. So a tree would be a pretty good one. If that tree looks like it's moving past you very fast, you're going very fast. If it's going by slowly, you're going pretty slow. This is all having to do with relative motion. That motion is something that we observe from a frame of reference. There's a young lady who is in a train. There's a man standing next to her. Let's say the train's going 60 miles an hour. The man doesn't look like he's moving at all. Both she and the man are moving, but relative to each other, they are not. If she were to look outside, she would see that the houses look like they're moving. Now, they're not really moving, but from her frame of reference, they are. If a second train were to come by and go past her, just going, say, 10 miles an hour faster than her train is, to her, that train looks like it's going 10 miles an hour. To someone standing on the side of the road, her train is going 50 miles an hour and the second train is going 60 miles an hour. So when you talk about motion, make sure you have a good frame of reference. The next two words are easy to confuse: distance and displacement. One is a scalar quantity, one is a vector quantity. What does that mean? Scalar means it has magnitude. You can measure its amount, but it doesn't tell you anything about direction. Vector has both magnitude and direction. So distance, if I say someone is 6 feet away from me, that means they're 6 feet away. It has magnitude. That's a good social distance right there. But it doesn't say if they're behind me, in front of me, to the east or the west. So if you want to know what distance you've traveled in a day, you would just count up your steps. It'd be interesting if this were a normal school year to figure out just what distance do you cover when you get out of bed, go to your classes, travel around, go back, go to your friends, finally go home, go back to sleep. What is the distance? There are some devices you can buy that will tell you how many steps you've taken in a day. Now, displacement is not concerned with the total distance that you've covered, just how far have you gone from where you started. So here's a guy, hits a baseball, and the baseball flies up in the air, slows down, then comes back down and gets caught by a catcher. The distance would be if you added up all the feet that it's traveled from when it leaves the bat to when it's caught by the glove. The displacement would simply be a straight line from the moment it hit the bat to the moment it touched the glove. How far away did it end up from where it started? Displacement is a vector quantity. It's not just a magnitude, but a direction as well. So I could say that the ball went 20 feet west. Total distance would be 60 feet, 3 times as much. Displacement and distance are not the same thing. They can be. If he had hit that ball in an absolute straight line and then it was caught, just a line drive, then the distance and displacement would be the same, but they usually are not. And the displacement can never be greater than the distance. Speed is a measure of how fast an object moves relative to a reference point. Speed is a scalar quantity. It doesn't have direction. So if I were to say I'm going 60 miles an hour, that doesn't really tell you if I went 60 miles in one direction or a different direction, or maybe just went in a circle and ended up right where I started from. But my total distance would be, 60 miles, and I did it in 1 hour. And that kind of tells you the formula. The formula is speed equals distance divided by time. Now, when you have a formula like that, a lot of times it's useful to write it out as a triangle. And I'll tell you why. They will give you on the final exam this formula: speed is distance over time. But they might not ask you for speed. They might ask you for time or distance. And you're going to have to rearrange the formula. And if you have a triangle like this, it's real simple. Cover up what they're asking you for, and there's the formula. The hard part is just writing it in the first place. You make a triangle, you draw a little T in there, divide it up into 3 sections, and then you look at the formula they gave you. Speed is distance over time. So I put S here, I put distance on top, and I put time underneath it. If I cover up the S, I see D over T, D divided by T. But suppose they said you're going 50 miles an hour and you do that for 3 hours. How far do you go? Well, if I cover up the D, I see S next to T, that's S times T. So 50 times 3, 150 miles. If they said you're going 50 miles an hour and you go 200 miles, how long did it take you? Cover up the T, and now I've got D divided by S. So 200 miles divided by 50 would be 4 hours. It's a useful way to go about things. If you look down at the speedometer of your car, you'll see how fast you're going at that instant, your instantaneous speed. It tells you what you're doing at that moment. But if you really want to know how long it's going to take you to go somewhere, you have to consider, well, it's going to take me a while to I have to stop for gas, use the bathroom, get lunch. I might hit traffic or some street signs. How long is it going to take me? You figure out, do the drive, and then if you want to figure out your average speed, you would say, I traveled 200 kilometers. It took me 2.5 hours. So speed is distance over time. So my total distance divided by my total time would give me in this case, an average speed of 80 kilometers per hour. Now, you may not have gone 80 kilometers an hour at any point in this trip. Maybe you usually were traveling at 100, and then sometimes you weren't traveling at all, but it averaged out at 80 kilometers an hour. That's what an average does. So that's speed, but what about velocity? A lot of people think velocity means really fast speed. Velocity is speed plus direction. So velocity gives you more than just speed does. And if they ask you, which is the velocity of something, make sure that your answer is not just how fast it's going, but how fast it's going and in which direction. So speed could be, this car is going 20 meters per second. Velocity would be 20 meters per second to the right, or east, or west, or whatever. Since velocity is speed and direction, you can change your velocity in several different ways. You could speed up, you could slow down, or you could stay at the same speed but turn your car so that now you're going in a different direction. All three of those is a change in velocity. And a change in velocity is our next word, acceleration. And this gets people really confused because a lot of people think acceleration means speeding up. They even call the gas pedal the accelerator. It is acceleration when you speed up, but so is slowing down. That's changing your speed. And a change of speed is a change in velocity. And so is keeping your speed the same, but turning your car. Now, one thing about acceleration, you can feel it. If you're in an airplane and the airplane's going 600 miles an hour, nice steady speed in a straight line, you just fall asleep. It doesn't feel like you're moving at all. But if that airplane is taking off or slowing down, coming for a landing, or if you hit turbulence where now it's changing its direction, you feel that. You feel that a lot. It's the reason why, even though the Earth is moving very fast, you don't feel that, because it's going at a steady speed. It is not accelerating. You were born into the Earth moving at that speed, and you'll live your whole life. It will never change. It's one reason why roller coasters seem way more exciting than they ought to be, considering how slow they're going. People think roller coasters are going fast, but they're not. They're accelerating, usually by winding and turning and doing all these crazy corkscrews and things to make the acceleration, give you that feeling you get when you accelerate. The formula for acceleration is a little more complicated. It's acceleration equals the final velocity minus the initial velocity divided by time, which means how fast you're going at the end minus how fast you were going in the beginning, divided by how long it took to make that change. And this is why Speeding up is a positive acceleration. So if I started at 0 and got to 30 miles an hour and it took me 10 seconds, it'd be my final velocity, 30, minus 0 divided by 10. My acceleration would be 3 miles per hour per hour. You're increasing every 3 miles per hour per second. Yeah. If on the other hand you were to slow down, so your final velocity is actually lower than your initial velocity. So I slow down from 30 miles an hour to 0. Now it's 0 minus 30 divided by 10. See, that's going to be a negative number. So I'll have a negative acceleration. Negative acceleration just means I'm slowing down. Positive means I'm speeding up. There's no formula for figuring out the acceleration of a car that stays the same speed and turns. Or if there is, we're not going to learn it. An example of a constant acceleration is free fall. You jump out of an airplane and you start falling. Gravity starts pulling you immediately, and it accelerates you at 9.8 meters per second per second. Every second that goes by, you are falling at 9.8 meters per second faster than you were the second before. So at first, you're falling 9.8 meters. That's almost 30 feet per second. And the second, you're closer to 60 meters per second, and you're going faster and faster. And this would continue until you finally hit the ground and left a big hole, except that there's another factor. The faster you're falling, the more the air is hitting against you. That's a force too. And that force will eventually equal the force of gravity. That doesn't mean you'll stop. You're still falling, but you're not going any faster. And that's terminal velocity, which we'll talk more about next week. And this also explains what happens with like projectile motion. If you just drop something off a cliff, you see exactly what I said. It starts falling and it falls faster and faster until it hits the ground. But if you throw it up in the air, it makes like a curve. Because as soon as it leaves your hand, you put a lot of force into it to get it up there. The more force you gave it, the higher it's going to go. But as soon as it leaves your hand, that force isn't there anymore. There's the force of gravity. And eventually that will slow the ball down, and then it will start dropping and it will fall just like if you had dropped it off a cliff. So if you want something to travel far, you can't just throw it to the side, because as soon as it leaves your hand, it starts dropping. You've got to sort of throw it up a bit and give it more time, more hang time in the air to get it further. A 45-degree angle will give you the maximum amount of distance. So there's our first week, and we will be speaking about several of these topics in greater detail in our face-to-face class meet. And please go take the quiz, the vocabulary quiz, week 1 vocabulary quiz, which will be graded. And I will see you all tomorrow. Thank you. Bye-bye.